uncertain, you feel no confidence.
Okay. Sorry about that.
So it's really up to you already. I can't do anything already. What grade you want is really up to you.
No, I want to pass the papers. I don't want to fail anymore.
I can't do anything. I just can only try to help you, try to advise you. You're big enough already.
Yeah.
Right? Let me persuade you, that's all. Okay. So let us start. Okay. We are.
Sir, but I don't know why, lecture, when you teach, like, makes it better, but when my school teacher teach, like, I can't even understand a thing also at all.
That's the reason I teach you. Then you must go back and force it in. The reason is you force it in. Then after very week, you forget everything. That's why it's very inefficient. You just spend 6 hours for one lesson, which is very inefficient. Normally, it should be half an hour to 1 hour, and then you should be able to understand. That's why you don't force it in. You forget. What I teach you, you forget. It's not effective, right? Wasting money. Anyway.
So just do it consistent, sir.
Yeah, it's up to you. It's really up to you. As I say, you have to put in the effort, find your mistake, your weakness, and overcome that.
The problem is, sir, you think I still got time or not, sir? I don't know.
You cannot spend so much time on a topic, right? The most I say is 1 hour, and then try to pass it paper. You spend 6 hours.
1 hour per topic.
1 hour per topic, and then go and try to pass it paper. Basically,
and if
the only way to memorize the formula is to keep on using it.
And if I don't understand the subtopic, then go read back, right, teacher?
If you don't understand the subtopic, then you can review again.
Okay.
To reuse your textbook because you know where to find the answer. That's the most crucial thing. So for this topic, all these things you must remember. Okay, this is just memory work. Always remember that your B must be perpendicular to the surface. That's all. Okay, C correct. This one also recognize which is Lenz's law, which is Faraday's law. Okay.
I put B, so correct.
So D is actually wrong also. D is not definition of electromagnetic flux density. Yours is a different definition. This is A level. Donkey is A level. Okay, as long as you recognize this, just to give you motivation. Okay, you got it right. Right? This one also you got it right.
Teacher, this one right, isn't it Weber? Just the unit because they say magnetic flux and density.
It won't come out. They need to know you know how to put a unit for the answer. That's all.
But this is unit for magnetic flux, not for the density one, right, sir? Density one you times n.
Magnetic flux density is Tesla.
Yeah. Oh, okay. They say the relay.
That's why I test you. All this unit must be there correctly in your answer. If not, you may lose a mark also. Now you start the question, the real one you don't know how to do. Simple thing you don't know how to do, you can see that. Very simple thing I teach you, you don't know how to do because as I said, you don't force it in. That's your problem. Right? You must be able to calculate the flux density BAN. A is by R squared. Right? Calculate that, put in your value, your B, change it to Tesla, pi, this one diameter divided by 2 times 10 to the power minus 2, change it to meter, then square it, 500 turn, right? Then after that, use Faraday's law. Don't worry about negative sign there. Change in flux over change in time. So it go to 0 from this value to 0, and that's your time. Calculate out. So answer is A. Okay.
Oh my God, this is like okay calculation, not so tricky yet.
This one is memory work. Flux, the magnetic flux through a coil varies with time as diagram.
This one don't have in the physics Ace Ahead book, sir.
Which graph best represent the variation with time of the induced coil? This is rotating coil. Right? I think the question is a bit poor. It didn't tell you it's rotating coil. But anyway, you must know Faraday's law. Right? You must know how to write the equation. And then you Faraday's law, differentiate it. So that is your E naught. So it's a cos graph minus cos graph. That's your A. That's all. A. Okay.
I think I got this correct.
Yeah, you got it correct.
Yeah.
This one is a bit weak. You don't know how to read. The EMF is induced in a wire subjected to a changing magnetic field. The flux density of the field varies with time t as shown, at which value of t is the magnitude of EMF induced in the wire 0. This is applying Faraday's law to a graph, that's all, that equation. Right? Substitute that one with BAN, A and N constant, so it's dB dt. So you get the gradient of the slope. So you want the EMF to be 0, the slope must be 0. So at this point, the slope is 0. At O and at 4, it is maximum. Right? Must be able to read the graph. EMF equals the gradient of tangent to the curve or to the graph. So at 4 millisecond or 0 millisecond, the largest gradient, largest EMF. So at 2, the slope is horizontal. Right? This one is horizontal. So 0. Okay. Anything not clear? Yeah, still very weak in all this. Apply the equation.
So you use go back. So you use that E equals to d theta over
Yeah, you use
dt,
this one.
and then just
take the gradient. That's all. Gradient. Gradient. This part, the top maximum is 0. Horizontal line. That is the steepest gradient at 4 and at 0. Okay.
Okay.
This one also getting you to use a graph. That's all. And this is your weakest point. This is how B changes.
DC, right, sir.
So you must be able to say, okay, gradient. This is constant. This is negative.
2t to 3t is constant.
This is 0.
Yeah, 0. It's 0.
Right?
Either the answer was C or boy.
So if you don't worry about negative sign, then you get the gradient, right? Gradient of tangent to a curve. So 0 to t, larger slope. Right? You must be able to say this is the larger slope compared to this one. So larger slope greater. If it's one negative, then it's below. Right? Since they just want magnitude, they don't bother about negative sign. Largest. After that, negative value. After that, 0. Okay with that? The answer is B.
So did I get this correct or wrong?
You got it wrong. You don't know how to read this type of graph.
No, teacher, why not C, teacher? I don't understand. I know it was either B or C, but why not C?
This slope is smaller. This slope.
Yes, okay.
This is deeper. How can it be C?
Oh yeah, so more larger lah.
You must be able to compare.
Okay.
Okay.
Because I know the 2t and 3t is 0, but then I wasn't sure whether B or C. But anyway, yeah.
A solenoid is connected in series with a battery and a switch. A hole probe is placed close to one end of a solenoid. The current in the solenoid is switched on. The hole probe is adjusted in position to give a maximum reading. The current is then switched off. So basically, it's just telling you, you adjust the hole probe properly, the hole probe is going to measure maximum magnetic field, that's all. So you don't have to worry whether it's at an angle or not, it's perpendicular. The current in a solenoid is now switched on at P. Again, several seconds later, it is switched off at Q. The hole probe is not moved. Which graph to show the direction with time of the hole probe? Okay, remember, you close the switch, the current is going to rise. Right? After some time, it will keep constant. Then after that, when I open the switch, it will decrease again. Okay, so the best answer is only B. Right? Best answer is B. Right?
Because it increased and
Hall
decreased.
probe measure Hall voltage, measure magnetic field strength. The Hall probe measures magnetic field. That you must know. Magnetic flux density. And then your B is proportional to Hall voltage. So when the switch is closed, the current takes time to reach maximum Hall voltage due to self-induction. The switch is off. After that, it's constant when the switch is closed. And after that, it decreases again when you open the switch. So the switch is off, open the switch, the magnetic field takes a while to be reduced to zero. Okay, so this is an A-level question.
Oh,
They approximate.
I think I got this correct, Lacha.
No, you got it wrong.
Eh, what did I put?
I don't know. You should record yourself.
No, I think I did put B, I remember.
Don't know how to read. Basically, you don't know how to apply your knowledge. That's all. Right? Direct question, you can answer. Applying your knowledge, you don't know. Okay, that's the reason.
Okay.
So you have to note for yours is exponential. Right? Exponential increase, exponential decrease. That's why yours. Your field is proportional to current. That is important for you to remember, not straight line. Right? Hot prop is now replaced. Right? This one is normal hot prop, small coil. Small coil is to measure the induced EMF. The plane of the coil is parallel to the end of the solenoid. The graph best shows a variation with time t of the EMF induced in the coil when the current solenoid is switched on and then switch off. So that is for your flux, how the flux changes. So if that's the flux, then you, right? Basically, as I said, you don't know how to apply your knowledge. Gradient, right? Important, gradient. You read no point. That's why I say it must do question, then you know how to apply your knowledge. Gradient.
Overcome the fear.
So gradient is constant. Yeah? The gradient is constant. They are not worried about negative signs in the model. Gradient, small time, not this one, right? Not this one, but this one. Right? Gradient is small, and then after that, negative gradient. You must be able to read. So answer is your donkey. Right? Use gradient. Right? BAN. Replace it. You got dB dt. Right? Remember, you are very poor in that. That's why all these applying your knowledge, you are direct question you can do. Okay. Right? But you need to remember, yours is different. Yours is a sharp decrease, so supply voltage. Right? But if you are worried about negative sign, then it should be the other way around. This one should be down.
Yeah, opposite.
See. Okay. Okay, this one also don't know how to do. Right? It's taken from your past year paper, from your revision book also. A metal rod of length L, which is placed on two parallel conductors. Right? These are your parallel conductors. These are fixed. In a magnetic field B, which is directly perpendicular into the paper as shown in diagram, the two parallel conductors are separated by a distance L and connected to a resistance R as a resistance. If the metal slides at constant speed, which expression represents the black force? Okay, remember the length is not the whole length, the length where the current flow. This is the length, the small L, not the big L. Right? So apply your knowledge. EMF induced is just your BLV. Right? I induced current is E over R. Right? Put the BLV inside. You got that? Then remember, you have to apply a force to the right. Right? So there will be a magnetic force to the left. Right? A current flowing, there must be a magnetic force. You must understand what's happening. When the induced current flow, That's going to magnetic force. Right? So BIL, I replace it with this one. Right? BL V over R. So BL L square V over R. Okay, so answer is donkey. Right? So there's your applied force. There's your magnetic force. Opposite to each other. That's why I move at constant velocity. Okay. Any comment?
No.
Okay. Right. So the magnetic force opposes the applied force. That is why that rod there, the dark rod there, move with constant velocity. Right. This one also very direct, but I don't know how to apply your knowledge. Right. I think transformer they won't come out. I just test you just in case it decided to come out. I tried the whole question. I haven't seen transformer. Right. So whatever they test you in STPM, they won't test you directly. But this one is very simple. Secondary coil of an ideal transformer deliver a root mean square current 0.5 ampere to the load. This part is 0.5 ampere to the load there, 8 ohm. The root mean square current, the primary is 0.1. What is the root mean square potential difference across the primary coil? So this one is just using simple, very straightforward. Power in secondary is I square R. Put in your value. That's your I, 0.5 square. That's your resistance. Right? So if usually our transformer is ideal, so whatever we put in, power output, power equals power input. That's all. Right? And power is P equals VI. So that is your output. Input is primary voltage. So primary current is 0.1. That's all. Very straightforward. Using formula. Okay.
Okay.
This one okay. Memory only. Right? I just modify the question from your book. Make sure you know how to define it. Usually 1 mark. This one is still very weak. Which of the following is not correct for transformer? For transformer, changing current in primary, current rise, give rise to changing flux in the core. Right? The current is the one that produces the flux. The flux current is changing, the flux is changing. Changing flux linked with the secondary. That means the flux move, the negative field join the secondary coil. So the coil in the coil secondary coil, the flux will be changing. Changing flux in secondary causes the induced EMF, correct? EMF is induced only when magnetic flux is changing. Right? When the current is changing, the flux is changing, then EMF is induced. For direct current, the current doesn't change. It's always constant, so the flux doesn't change. So in this case, the transformer doesn't work with direct current. Okay, so A and B correct. Induced current in the secondary is in phase with the primary current as both change together due to changing flux. No, right? The current change in the primary induce the changing current in the secondary, but we have Lenz law tell us that it oppose. Oppose means it won't be the same phase anymore. So C is the wrong answer. The flux in the core is in phase with the current in the primary coil. The primary current is the one that produces the flux, so they must be in phase, but not in phase with the induced EMF. Right? There's your Lenz law. In the secondary, because the flux cuts the secondary coil, flux and rate of change in flux are not in phase. Correct. So C is the wrong answer. Right? Basically, we are just using the formula. Right? The current in the primary causing the change in field. The change in field called a change in flux there. So that you can represent it with a simple sine graph for changing flux. That is the primary to the secondary. Then induced EMF, right? Induced EMF, you have to differentiate it. As long as you differentiate it, they are no more in phase. Right? In phase means they must be, if this is sign, EMF must also be in sign, not negative sign also, but this is cause. So they are not in phase already. Okay with that? Refer to your note.
Okay.
Okay, so the magnetic flux density.
Wait, sir. So your notes, right, sir?
Yeah.
You have everything there, like, sir, basically, right?
My notes cover everything. Some of it are not required anymore. If you look, if you do your past paper, you find that some of it are extra. Right? It's just
Right,
that
so actually teachers suggest that I do the revision for 1 hour, one topic, then go do the past year. If I still not sure with the subtopic, then go through again, right? Until you expert.
Basically, you should know memorize all the formula. Basically, you memorize formula, you don't know how to use it, no point. Right? You spend too much time on 6 hours is too long. It should be 1 hour review through and then do the topic. Areas that you know you are weak in, go and try your revision book. The revision book
only go through back again.
Review through and try to understand. Okay, this one you can do. A coil has
this one okay.
Right? L is given. Current in the coil is reduced from 25 to 0 in 1 second. You want to find the induced EMF in the coil. Right? So memory work. That formula. Right? As I say, you don't need to worry about negative sign, negative, so lens off. So this one change it to SI unit. Then 25 divided by 1, that's all. Right? So good. This one you know how to calculate. See, this one you are a bit weak. The solenoid of length, usually solenoid, instead of testing you in previous topic 16, they will test you in 17 under in electromagnetic induction. That's why you hardly see solenoid in 16. Solenoid of length 0.75 meter has 100 turns. The cross-sectional area of solenoid is given. Cell inductance, this one is memory work. The formula, you can't remember formula, you're gone. Right? Remember number of turns square. Cross-sectional area, mu naught, and then divided by length of the solenoid. Right? So that is your mu naught from your value of constant. That is your area. Remember, right? It's convert for you, so it's okay. 1,000 square. L is 0.75. Put in there, calculate out. Answer is B. Okay. Right? This one is also in your book. I will go over you the answer, but it's still a bit blur. Coil A is connected to a battery. That's a battery. Resistor and switch. That's a resistor, that's a switch. Which of the following is false when the switch is closed? Just understand. The switch is closed. The current takes time to rise up. So when the switch is closed, the current rises. Right? Take time to rise. The field produced link the coil B. Right? So the field, the current produce a field. The field pass to the secondary coil B. Correct. Lenz law tells us that an induced current in coil B will produce a field to opposite. So it means that Lenz law tells us that there is a field. Right? In this case, you should be able to tell the field is going using your right hand grip rule. Right hand grip rule tell you that that is your field. That direction is a field. So Lenz law tells us the opposing field will be in opposite direction. Right? In opposite direction. Sorry. The current in the coil facing each other are parallel, right? Opposing each other. So the current must be parallel to repel. Remember, they must repel. They must oppose. D. When the current is constant, the induced EMF is 0, correct. When the current is constant, no more changing, no more changing flux, no more induced EMF. Okay, so C is the wrong answer. So when the switch is closed, the current rises. The field from coil A passes to coil B. That's what we say. Induced current in coil B produce a field to oppose the field. So the current must be anti-parallel. That's why it is. The two must be anti-parallel. Cannot be parallel. Parallel, they will attract. You want to be opposed. So it must repel. Okay?
Okay.
This one okay? Loop of wire carries a current 80. The magnetic flux produced by the current is Weber. What is the cell inductance?
The answer is donkey.
Memorize the formula, that's all.
0.40 divided by 80 times 10 to the power of 3.
This one, yeah, okay.
Direct question, answer.
Direct question, yeah. Just try to test whether you remember your formula.
But I know STPM, they won't ask like that.
Sometimes they may do that in your B and C. Right? B and C is quite straightforward. It's just that you're
the answer is A. The answer is A. The answer is A. 18.
Right? This one is a memory work, that's all. A coil of length 20, number of turns is placed coaxially inside the solenoid. The solenoid is a coil of cross-sectional area 4.2 cm square, which has 100 turns, which is the mutual inductance of the arrangement. What is the mutual? Not which is, sorry. Let me just change it.
I used that formula.
That formula, that's all. You got it wrong.
4 pi times 10 to the power of 97 times pi. Wait, times pi. Wait, isn't it you add another times pi there? I saw in the book. Teacher?
Yeah.
Oh, no, because in the book, right, they put that extra pi, 4 pi times 10 to the power of 97 times another pi.
Where got another pi?
In the book, the Ace Ahead book? Or the book Salah?
Where got another pi? This is a 4 pi is a mu naught. Where is the other pi?
That's a reference book, that's what I meant.
There's a mu naught.
Right? So you got your Ace Ahead book with you or not?
That's your area. Unless you use radius and there's another pi. The area is already given you.
Oh.
Then number of turns. Number of turns. That's your length. That's your length. Okay?
Oh, okay.
That's why I say don't do enough problem. That's why you are having problem. You cannot pick out the mistake.
I need to keep doing until I okay with it. Okay. Understood.
Right? This one is memory work. I know you didn't do your revision book exercise. That's why this is direct question. You don't know how to do. Coil of wire wound on a soft iron core is connected in series with a switch. That's your switch. And the battery is shown in the diagram. Right? That's your battery. They are all in series, a coil, battery, switch. The switch is closed at time t equals to close and then open when t equals to t. Which of the following graph represent the current I in the coil against time? Right? So it will exponentially increase. Answer is donkey. Right? Due to rise in current, back EMF is large initially. That's why the current is small. And as the back EMF starts to decrease, the current starts to increase to a maximum. Then when you switch it
the self-inductance formula.
Okay. So R is the resistance of the coil. That's all. Okay with that?
Answer is donkey. Yes.
Donkey.
Okay. No, but I don't understand how they draw the graph part. Sorry.
Okay. The current rises slowly because of back EMF.
Okay.
Then after a while, it is constant. Then when the switch is closed, when the switch is open, right, the current starts to decrease again. That's all. Okay. It doesn't go straight away to zero. It starts to decrease slowly. Right, this one you're all right. Direct.
Answer is A.
Just to give you motivation, that's all. Know how to memorize the formula. Sometimes they do ask you direct question. A, they want to give you the mark. They just want to test you whether you remember the formula. Right? It is also taken from your past year paper. I just change the order, that's all. There's your metal PQRS, QRS, area given, resistance given, displays the uniform magnetic field. That's your field strength given. Joint diagram. If the magnetic field decreases to zero at constant rate in 0.5 seconds, what is the magnitude and direction of the induced EMF? Right? So the key to remember is the field is going in. So the first thing is to know how to use your right hand curve rule. Right? The fingers represent the current, the thumb represent the field going in. Right? So it's clockwise. The current is flowing clockwise. Right? That you must know. So when you switch it off, the current must still flow clockwise because you want to stop the field from decreasing. Okay. Then the next part is to calculate. Answer is donkey. So this is a question that taken from a book. That's your. You must remember that rule. Right? And the formula. Right? Flux is DAN. B is the one changing. A and N constant. Then this is in cm. You have to change it to meter. That's why there's a -4 there. And then your N is 1. B is 2. Right? Time is 0.5 seconds here. Calculate that. And after you calculate your EMF, calculate your current, induced EMF over resistance. For the field to be into the page, the current must go clockwise. So Lenz's law will tell us that it will try to maintain the induced current. That's why the field must still be into the page. Okay with that?
Okay.
Anything else you want to ask? Our time is almost finished.
No, answer the past year questions. Number 2. Last one. Essay.
Past year question number 2. I think we still got 5 minutes. Okay, we can try that.
Sir, can I ask you something, sir?
Yeah.
I mean, sir, you're very hardworking and I quite malas, but then teachers still want to teach me why.
Say again.
No, I mean, teacher very hardworking. You do all the solution, question, everything, take your time. But then I'm the one like super malas. But then teacher like still why want to teach me like that?
I try to help you. As I say, I'm not looking for money. Okay, I'm trying to help you. I know, right? If I'm looking for money years ago, I will reject you straight away. Already. I will give out on you. But I think you can still be helped. It's up to you. That's why I'm persuading you. I pray for you.
No, because if because I was doing this all the while, all teacher would have quit me long time ago. But then teachers still want to teach me. That's why
I am not. As I say, I'm not looking for money. If you're looking for money, I will give you up again. Already. But as I say, I'm trying to help you. I didn't give up on you. Right? That's why I told your mother, I will scold you. I won't run you down. I will encourage you until you see
think I can still do it.
The mistake of you can still do it if you want to do it, but it's up to you. I cannot force you. Right? I thought we have done already. Question 2.
No, question 2 I haven't done yet. The question 1 did ready.
Okay.
Question 1 it did. Question 2 didn't do.
Okay. First thing, you got a charged particle
Essay, teacher, essay, not objective.
You don't
Sorry,
have
essay.
already. Our time is almost gone already.
Okay, just go through fast, sir.
What am I doing?
For the structure.
Right, take Ampere's law, that one you should be able to do that. Using Ampere's law, derive, that one you should be able to do that also. Right, consider a loop of radius R, carry a current I, right, conductor carry a current I, and then you want a circular loop, apply Ampere's law, B 2 pi R, you know I, then get your answer. Right, I work every day, except weekend, that's all. Right, that's why I say you must follow my style. Okay, a cross-sectional view. Right,
Sorry, I'll try my best from now on, sir.
Right. Cross-sectional view of 4 cable with carry current is shown in the diagram below. This is a very popular question. Current I1, I2, I3, I4 are given value. Draw the magnetic field at C due to the respective current. Right? So essentially, you must know this right-hand curve rule. The thumb represents the current, the fingers represent the direction of the field. So these are all circular fields. Right? Due to your I3, it will be in this direction at C. Right? Due to this one also, this one is going in. So it will also be, that's your B1. B1 is due to I1. Right? B3 is due to I3. Both are in the same direction, same magnitude. Right? So the key is to find the diagonal, half the diagonal here, that length there, I call it A, and then because it's a square, this 90 degrees, 1 root 2, you can remember that. If not, A square plus A square is 10 square. Right? Find the A, right? That length is A. So X, right? These two add together, B1 and B3. Okay, I'm just using this formula. Okay, there's your mu naught. Then your 2 pi R is that, your A, and same direction, right? I1 and I3, I1, I3. Okay, calculate out. Then you do for B2, right? B2, right? I think we will be cut off already. If you want, I can start a new Zoom and try a short time.
Can, teacher.
Okay, I'll stop here lah. Give me about 5 minutes.
Okay, sir.